We're back. And are you ready? Because I am, I don't know why, ready. But, yeah, we're ready. Okay, so measures of dispersion. So, what we need to look at, well, what would be useful to look at now is so far we've looked at mean, median, mode. And we asked ourselves questions like which one was useful, when, and to be honest, only so useful. All of those are only so useful and only get you so far. Often people ask, pupils ask in a test, what was the average of the test? And I'm like, I don't know. Well, hey, how does it relate to how you're doing? Are you comparing yourself and seeing that? But how have you improved? Different sections you do differently. So it's a oversimplistic way of looking at things of just going compared to average. What would be more useful is to see more things to do with your data without looking at the whole set, to look at a few things. So we're going to look at a few here and go the range. All these are written up here, so I'm not going to go, oh, what's the range? Write it down. Or am I? No, I'm not. Okay, well, that was a silly way of doing it. And so the range is the largest minus the smallest. So let's look at something like our beloved test marks, and we go, well, somebody in the class got 11, and somebody got, 34, and the test, who knows, was out of 50. So then we can say, well, the range is 11 up to 34. If there were, 13, 15, 20, a whole lot of people in between, the range is biggest minus smallest. Makes sense. Quartiles. Okay, the quartiles are when we divide it up into 4. So quartile into 4. So if we've got our data and we say, here's our data and we want to divide it up into 4, well, we can say, where's the middle bit, where's a quarter into the data, and where's 3/4 into the data. Because, of course, we've got the minimum over here, and we've got the maximum here. So the minimum, the maximum, and then we want to just divide our data. Now, that's quite nice. It's quite useful. Why do you think it's useful to be able to divide our data up into 4 sections? I was always interested in hearing that. And one way would, maybe it kind of shows where most of the data is. So our heights. In fact, let me do this with the heights. If we had our heights and we had, here a whole lot of people here somewhere, and then suddenly you had, let's keep most people like vaguely there, and then you got some person over here. If we divide it into quarters, in fact, let's really take this a little bit further to get your photos off the system at school, hey, and then we can line you all up and according to your heights. But if we looked at this, we could say, well, here's our minimum, here's our maximum. Our halfway point is somewhere over here. I'm not counting them up to get exactly where it is, so please don't count and go, it should have been the next one along. So our middle point person is about this height. But a quarter into the data set, our person's a similar height in 3/4. So now we can tell, hey, most people are kind of this height, and this really was an anomaly, this big height over here. Because even 3/4 into the heights, somebody was a certain height. Okay, let's get into an example. Maybe it'll help more. And we're going to look at interquartile range is just the third minus that. So basically, what's that quarter? And semi-interquartile range, we divide and divide by 2. Okay, which is sort of like an average there. And we're going to do this in this lesson, and we're going to see it in the box and whisker. So we're going to see it quite nice and visually in the next one as well. So just take note that this measures of dispersion goes from this into the next. That's enough rambling around. Definitely is useful to have a bit of the rambling. Just think about what we're doing. We're not just about, okay, let's calculate it. Okay, so let's look at our stem and leaf. Shows the ages, rounded to the nearest year, of 44 patients seen at a specific clinic, or specific day at a clinic. Okay, so a whole lot of people are coming into this clinic, and they're from one, well, let's see. Use the stem and leaf to determine range, lower quartile, median, upper quartile, interquartile range, and semi-interquartile range. And let's see what each of those tell us. I'm going to add I'm going to add 2 in this to start with. What is our minimum value? Okay, well, our minimum is 1 because it's 0, 1. What is our maximum value? Well, here it is, it's 93. Okay, now let's go for our range. What is the range of our data? Well, it goes from 1 up to 93. So it's 93 minus 1 gives us 92. Huge range of everyone from 1 up to 93. Okay, what next do we have here? So we've got the range, the lower quartile. So the lower quartile is Q1. Now before we work out the lower quartile, I think it's more useful to work out what our median is. What is the median again? The middle one. So if there are 44 patients, where is the median? So 44, so we'd go, well, it's an even number, so we know we're going to have 2 in the middle. So our median is going to say, well, 22 and 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So it's these 2 over here. Okay, so there's our median. So therefore, what is the median? Well, it's between 54 and 56. So our median is, where am I writing this here? Median, let's move that side, is 54 plus 56 over 2 gives us 55. So it's like there was a 55-year-old. That's the middle kind of number. Now, for Q1 and Q2, how do you think you're going to see where Q1 and Q2 are? Okay. I'm hoping that there are lots of different answers for this, because there are a few different ways of doing this. The one is to say, well, we've got 44, so you went, oh, well, Q1, it's a quarter of the way in, so it's the 11th data point. But is it really? Or you might have said, well, we split our data into half, so here's half. So therefore, if we looked at our data set of this, and then said, where's the middle of that data set? And the other half of our data is this part. So you're saying, well, where's the middle of this one and where's the middle of this one? Okay, different ways of doing it. Do you include or exclude this 54 and 54 and 56? So should this have gone, you know what? Let's take the middle. And we're saying, well, we don't need those 2 because those are in the middle point. So there's the first half of the data. And there's the second half of the data. Okay. So option, now you need to vote. Which one do you think is best? Very briefly, why? Option A, 44 divided by 4, the 11th position. Option B, we took the data set and we divided it into 2 like that. And that. So we included those both of those middle bits. So in half and include, why am I stuck with 44? 54 and 56. Or option C, you still split the data set in 2. But you exclude that because that was our middle point. So we don't need it in here. Let's exclude it and say they're the 2 halves. And so in half as well. But we're going to exclude the 54, 56. And that was the include. Cast your vote quickly. Why do you think you've chosen the one you've chosen as well to get wherever this middle value is on each side? Okay, now all of them have their issues. They really all do. And if you've got, this is an even data set, think about what happens with an odd data set. So if you've got an odd data set, let's say you've got 5 points. If you split it into a quarter, where's a quarter of the way in? There's your middle point. That's easy. So do you include it and say this is Q1, Q2? Do you exclude it and say Q1 is over there and Q3 is in the middle? Maybe I should have done those with other colors. So is Q1 over there or is Q1 over there? And is Q3 over there or is it over there? 1, 2, 3, 4, 5. None of them are perfect. Q1 isn't even either of these. Maybe it's sitting over there. Okay. Now, the truth of the matter is that all of these things don't really make much sense in our tiny little data sets. And when your data sets are huge, it makes less of an issue. So, we're going to just opt for one way of doing it always. We're going to include these bits in the middle when it's an even data set. So we've got, so we said, I should have left that bit there. So we're going to go for, this is our first half. So if that's the first half, just looking at that part of the data, what is Q1? Well, there are 22 data points. So we must be looking at 11 and 12. So let's see, 11 and 12 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we must be 21 plus 29 over 2. I think that's 50, gives us about 25. So in other words, there's the first half. Now for that was Q2. For Q3, we're going to look at this half of the data set, including that middle bit. Okay, and for, let's move it down here, the upper quartile, which we're going to call Q3, because our median is Q2. Then we're going to go this, we already said there are 22 data points if we counted them all up. So 22 divided by 2 is 11. It's an even number, so we must take 11 and 12. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I think it's those ones. Correct me if I'm wrong. 68 plus 69 over 2 equals, I'm going to need this for this. We've got 68. I don't need the calculator. Why am I being silly? Why do I think I need a calculator for this? What's halfway between 68 and 69? Sometimes, 68 and a half. Who saw that and thought, why is he getting the calculator out? That wasn't too bad. Okay, and the last 2 points. Let's go run through them. We've got the interquartile range. Well, that's easy. The interquartile range is just how much is there between Q1 and between Q1 and Q3. So we can go that's 68,5 minus, in the way there, minus, I wonder if that did, minus 25, so let's get that there, equals, well, that's easy, that's 43,5, and the last bit is to do the semi-interquartile range. I wish there were a nice shorter way of writing that, but the interquartile range is, well, it's just that thing divided by 2. So 43,5 over 2, which is 21,75. So it's like every 21,75. Okay, so there we go. There's a way of looking at our data, so we've split it up. I'm really looking forward to the box and whiskers, because what we're going to do is we're going to turn all of these things we've just done and we're going to make it visual. And that's I think really useful to see this more visually. Okay, that's that. Enjoy the exercises from this, from the previous Ed puzzle. Of course, for this, your exercises are going to be part of the box and whisker. Okay, see you in the next one.